Let's move on. Number 8. Charlie and Daniela each began a fitness program. On day 1, they both ran 500 meters. On each subsequent day, Charlie ran 100 meters more than the previous day, whereas Daniela increased her distance by 2% of the distance ran on the previous day. So we need to calculate how far Charlie ran on the day 20 of his fitness programming, and Daniela ran on the day 20 of her fitness programming. So the tough part here is understanding like how Charlie increases his meters ran and how Daniela increases her meters ran. ¿Cierto? So for the case of Charlie, see, on day 1, right, uh, he was at 500. See, on day 2, right, he ran 100 more than last time, so it's 500 plus 600. ¿Cierto? Sorry, 500 plus 100. I said the answer aloud. 600. See, for U3, it's 600 plus 100, 700. See? Well, you get what's going on by now. U4 is going to be 800, etc. So this is the nature of how Charlie's increases. See? Now let's look at Daniela. See? Daniela. U1 is also 500, so that is something in common. U2, it increases by 2%. So it's 500 times 1.02. See? And that gives me 500 times 1.02. That 510. U3, it increases by 2%, so it's 510 times 1.02 gives me, let's see what is going on over here, 520.2. Dale. So, yeah, we can keep going here and we can get to U20 and take a really long time. But there's obviously quicker ways. See? Now, why is it important to do this? Just the first couple of terms to understand the nature of Charlie's running and the nature of Daniela's running. The nature of Charlie's running is this thing called arithmetic. Arithmetic what? Arithmetic sequences. See? It always increases by plus 100, no matter what. See? So this is actually D equals 100 in our formula booklet. For Daniela, it increases in a different manner, right? It's like a little bit more exponential. This is what we call a geometric sequence. See? Again, I'm pulling out fancy math words, but you need to understand this the intuition of like how each of them increase. ¿Cierto? The one on the top is plus 100 each time. The one on the bottom doesn't increase by a flat number. ¿Cierto? Here was plus 10. Here was plus 10.2. Later on, it's going to be like, dude, I don't know, 10.8 maybe. Like, who knows? It doesn't increase at the same rate each time. I mean, sorry, the number that affects it isn't the same one each time because there's a certain rate to it, right? A 2% applied to it each time. And so that is just useful to identify the geometric sequences and know how to approach this. So the one on top has D equals 100. The one on the bottom, the 102, the 2% is going to be R equals 1.02. See? And so now that we have this information here, and both U1s, which is way more useful than what we think. Whoops, let me try that again. Both U1s. We can go to a formula booklet. Since we're talking about sequences, we're going to go here. And bada bing bada boom, ¿cierto? So the nth term of an arithmetic sequence is the one on top. This guy here, ¿cierto? And for the nth term of geometric, it's this guy there. ¿Vale? So those are the equations I will be applying now. It'll look something like this. So again, for Charlie, we're going to go with Charlie first. Charlie, we have U20 equals U1, which is 500, plus N, which in this case is 20, ¿cierto? 20 minus 1 times 100. See? So if we go ahead and solve that, we're going to end up with U20 being equal to 2,400. See? Trust me, you can use your calculator. For Daniela, we have a similar approach, just that we use the other formula. So UN, U20 will equal U1, which is 500, times R, we said was 1.02, to the power of N minus 1. N is 20. We have the minus 1 here. So U20 equals 500 times 1.02 times to the power of 19, sorry. And this gives us U20 equals, in this case, 728.405. Cool. So that is for part AI, ¿cierto? And for part A double I, it's down there. See? Then they tell us on day N of the fitness programs, Daniela runs more than Charlie for the first time, right? Why does this happen? Because Daniela increases exponentially. ¿Cierto? It's a geometric sequence. She's going to catch up to Charlie eventually. Charlie might get a massive head start, but it won't be forever. Daniela will beat him eventually, no matter what. So, what we have to do here, ¿cierto? Is take our formulas for nth term and have Daniela's be bigger than Charlie's, because that is what it's telling us. Cierto? Daniela at some point runs more than Charlie for the first time. So I'll actually do it up here. Maybe it'll make more sense. So for Daniela running, cierto? It is 500 times 1.02 sum n minus 1, cierto? And this has to be more than, because it's what they give us here, cierto? Runs more than Charlie, cierto? And what was Charlie? Charlie was 500 plus n minus 1 times 100. See? And so now I actually just need to figure out n, and I'm good to go. See? Right, so now we will be taking this guy into y1, so it's going to be one equation. This guy into y2, it will be my other equation. We do calc intersect, and that will give us like the key point of n that will help us like interpret what value of n we need to find. ¿Cierto? So wherever Daniela runs more than Charlie for the first time, remember that Daniela is the geometric one. So it's going to be the curve that looks a little curvy. And the other curve is really just going to be a line. Charlie's going to be a line. Daniela is going to be curvy. See? Okay, anyways. So we take our equation here. We make sure we plug in everything. ¿Cierto? And we play around with our window until we get the value that is needed. So y is probably going to be pretty big. So I'm actually going to put like 5,000 and see what happens. X is days, so I expect it to be much less. Let's put 50. See what happens. All right, so now we can see that this window is not great, but it's important to see why. ¿Cierto? So the way that I have it drawn, right, is something like this. ¿Cierto? So that is what my window is showing. What I want to reach, ¿cierto, is a point where, okay, this guy keeps growing, and this guy intersects and becomes bigger, ¿cierto? And wherever it becomes bigger, that is the value of n I will be trying to find. See? And so I'm not quite there yet, and I need to keep playing around with my window and see what happens, ¿cierto? So it seems like my x has to be a whole lot bigger than what I expected. And I'm not sure about my y max. So let's take a moment and see what happens. All right, again, I need to be able to see it. I know this is a little bit tedious, but I'd rather have you guys see the process behind it. ¿Cierto? No one nails their window right away. And, you know, it's part of it. All right. I think third time's a charm if I'm not mistaken. But let's see. Let's see. Woo! All right, finally. So that is where they intersect. ¿Cierto? So second, calc, intersect. First curve, second curve. Now we have guess. For guess, just put it near where they intersect. This is because some lines have more than one intersect, and you need to like show which value you want. ¿Cierto? So okay, that value there, that n, is just about 184.215. See? So any this is where it intersects, right? So right at this moment here on the 184.215, these equations are the same. That means that Daniela and Charlie are running the same amount of meters right at this day. See? Now anywhere beyond that day, we're talking about this here, which is Daniela being running more. See? And so because it's in days, ¿cierto? Um, and the context of the problem, well, what's the next day after like day 184.215? Well, it has to be day 185. See? So you can put it like that for part D, or you can say n being greater than this value. See? Because n being greater than this value, we're talking about these values there, which are all greater than what Charlie would have run. So that is for part B. I think I said D earlier, sorry about that. Part B. See, that is how you do part B.